Okay, this is the first circuit we have seen that is not almost totally trivial to analyze. So let's look at it. I am claiming that the item marked load down there at the bottom. Note that the load here has one end grounded. Only one end of the load, only one terminal coming out of that load is connected to our circuit, which I claim is a voltage controlled current source. Now that ground terminal might be multiple connections to ground or through the power supplies, since if you've got a power supply, voltage source, it effectively is connected to ground through the voltage source. So the whole point here is that you have a single terminal into which you're going to squirt the current I sub L. Eventually it will return to ground by some method or other. Maybe a little bit more complicated than just a single wire to ground. Okay, you may look at this and say, what the heck, how do I start? Because I don't know what the voltage at the non-inverting input is. I've got negative feedback, so if I knew what the voltage at the non-inverting input was, I could figure out what the voltage at the other one was. But let's approach this one a little bit backwards. I do know that I've got negative feedback, therefore the voltage at the inverting input will be the same, whatever it is, as the voltage at the non-inverting input. I don't have an easy way to get a handle on that because I've got this current I sub L going through the load, so I can't immediately get a handle on what the voltage at the non-inverting input is. I can't really get a handle on the current through those two bottom resistors. But what I can do is I can say, okay, I know the current into the inverting input is 0. Thus the current through the two resistors at the top is the same. In other words, those two top resistors are effectively in series. Thus, voltage division applies across those two effectively series resistors at the top. I've got a total voltage of V out, from V out down to ground. And since the two resistors are equal, voltage division says the voltage at the inverting input, the point between those two top resistors, is V out over 2. Since I have negative feedback, I know that this is reflecting what the voltage at the non-inverting input is. So now I know what the voltage at the non-inverting input is. It's V out over 2 as well. In other words, the op-amp is going to do whatever it must to ensure that the voltage at those two terminals is the same. Now, again, we don't really have an easy way to figure out exactly what V out or V out over 2 is, but let's continue our analysis here. Now that I know that the non-inverting input is V out over 2, I can get a handle on the current through the bottom left resistor, the one connected to the input voltage V sub I. So the current through that lower left resistor is VI minus V out over 2 divided by R. I can split those into two pieces, VI over R minus V out over 2R. So that's the current through that bottom left resistor. Now I also know what the current through the lower right resistor is. That has to be V out minus V out over 2, which is just V out over 2, divided by R. So the current to the left through that bottom right resistor is V out over 2R. Now, Kirchhoff's current law, none of the current can enter or leave the non-inverting input. We assume that's 0. Therefore, I sub L, the current through the load, has to be the sum of those two currents. So it's got to be VI over R minus V out over 2R, that's the current on the left, plus V out over 2R. Now the V out over 2R terms cancel out, and I'm simply left with VI over R. That's I sub L. So in other words, I've now got a current I sub L which is dependent only on V sub I. Oof. Now, the selection of the value of R gets into some practical considerations, and we'll discuss what those practical considerations might be later on when we talk about some of the non-ideal characteristics of op amps. But for right now, this circuit topology will allow you to implement a voltage-controlled current source into a grounded load. All right, next up will be current-controlled dependent sources. Aha!